Hello, friends. Welcome to Science Talk. I am your host, Jim Massa. I want to share with you a couple articles that are published in the online publication journal, the Energy Mix, and it's a contrast between wet and dry. So, first, let's look at this one here. Human induced climate change made the BC superstorm 60% more likely, study shows. And here is a bit of a devastation. Excessive rain caused, trees to get wiped out, mudslide. It's like took out part of a road, or at least blocked the road. All this mud and so on. You can see devastation. You can see some standing water here, or perhaps mud, but not passable for sure. And to give you a scope of it, there's a tractor trailer back there and there. So this is a significant devastation there. Atmospheric rivers, basically referring to jet stream. We know that jet streams are changing. We know they're going from a zonal flow to a meridional flow. So it just picks up the warm oceanic moisture and brings it to wherever, and then just dumps and pisses away on whatever's underneath it. So atmospheric rivers, as powerful as the one that devastated British Columbia in November 2021, are 60% more likely to occur due to human-induced climate change. The 48-hour deluge that the storm delivered to major parts of the province was made 50% more likely by anthropogenic climate change, according to a preprint. Okay, it has not yet been peer-reviewed, but it's in the process of being peer-reviewed. And it was co-authored by scientists at the Environment and Climate Change Canada, University of Victoria's Pacific Climate Impact Consortium. Using a large ensemble of simulations that integrated multiple climate drivers, the researchers estimated that the extreme stream flow events experienced in several mountain basins in the province while caught up in the atmospheric river were between 2 and 4 times more probable, depending on the basin, due to human-induced climate change. Despite the largeness and intensity of the storm, the atmospheric river was not unprecedented in size, research shows. Based on the amount of water vapor it contained, the atmospheric river was about a 1 in 10 year event, the team estimated, but based on the amount of rain it ultimately delivered, the deluge was found to be substantially more extreme, approximately a 1 in 50 to 1 in 100 year event. With peak stream flow, which is defined as the volume of water in streams and rivers as well as surface runoffs, taken into account, the atmospheric river exceeded 1 in 100 year events in several basins. The very high precipitation during the event was the primary driver of that extreme stream flow, but snowmelt associated with a rapid rise in temperature during the event also made a significant contribution over moist basin. That's an important point. You warm up whatever snow you had, probably at an altitude, you warmed it up, or you have rain falling on it that helps melt it, because rain is liquid, so that means its heat is higher than what the snow has. That will lead to, torrents of water flow, mudslides, taking down trees, those kind of processes. The researchers dismissed concerns that loss of topsoil stability due to wildfire may have contributed to the extreme stream flows. Well, it depends on how much topsoil was lost, but it is kind of established, basic scientific principle that if you lose topsoil, rain, or if you have a fire, right, it destabilizes the topsoil. That excessive rain will wash that away. So I'm not sure. I don't understand why they're dismissing that, to be quite honest. I'm sure during the peer review process, the referees will probably have something to say about that if it's included in the paper. Authors warn that the probability of such events is expected to increase further in the future, demonstrating the importance of developing increased resiliency to such events here in BC and across the world. So, increased temperatures, warmer air. Warmer air can hold more moisture. Really that simple. And so we have here wet area. And, if the jet stream is flowing over the ocean and the oceans are warmer and you've got evaporation increasing, it's just going to pick up that moisture and bring it. And then when it cools down, it's just going to piss away on something. And that's what happened here. So we have this extreme wet event. And now to the dry. Also appearing in the energy mix. Worst case climate scenario plays out live as Mexico and the U.S. West face worst drought in 1,200 years. And you can clearly see the drop in water level here, right? You can tell by the vegetation that water was this high, and then extend that across the way. That is a significant drop in water volume. The America's West mega drought deepened to the point last year that is now the driest in at least 1,200 years and is a worst case climate change scenario taking place in real time. A dramatic dry in 2021, about as dry as 2002, and one of the driest years ever recorded for the region, pushed a 22-year drought past the previous record holder for mega droughts in the late 1500s, and shows no signs of easing in the near future. And based on a report published in the journal Nature Climate Change. The study calculated that 42% of this mega drought can be attributed to human-caused climate change. Climate change is changing the baseline conditions toward a gradually drier state in the West, and that means the worst-case scenario keeps getting worse, said study lead author Park Williams, a climate hydrologist at UCLA. Williams studied soil moisture levels in the West, which includes areas such as California, Wyoming, Utah, Nevada, Arizona, most of Oregon, Idaho, much of New Mexico, western Colorado, northern Mexico, and the southeast corners of Montana and Texas. I just basically say half of the bloody continent. Okay, well, at least half of the continental U.S. They used modern measurements from tree rings, dendrochronology and dendroisotopic fractionation. Right? That's basically what they were using. I can tell without even seeing the methodology in detail that they were using isotopic fractionation to recreate temperature, dryness, etc. And they were able to go back to the year 800. That's about as far back as the technique can deliver reliable estimates. In other words, where the errors are not so large as to make the results really not of much value. A few years ago, Williams said the current drought qualified as a lengthy and deep megadrought, and that the only worst one was in the 1500s. He figured the current drought wouldn't surpass that one because megadroughts tended to peter out after 20 years. And he said 2019 was a wet year, so perhaps the Western drought might be ending after all. But the region dried right back up in 2020 and 2021. All of California was considered an official drought from mid-May until the end of 2021. At least 3/4 of the state was at the highest two drought levels from June through Christmas, according to the U.S. Drought Monitor hosted by the University of Nebraska-Lincoln. For this drought to have just cranked up back to maximum drought intensity in late 2020 through 2021 is a quite emphatic statement by this 2000 drought saying that we're nowhere close to the end. This drought is now 5% drier than the old record from the 1500s. 5% drier. The drought monitor says 55% of the U.S. West is in drought, with 13% experiencing the two highest drought levels. This mega drought really kicked off in 2002, one of the driest years ever, based on humidity and tree rings. So he goes on to say, I was wondering if we'd ever see a drought like 2002 again in my life, and we did indeed see it 20 years later within the same drought. A drought within a drought. The drought levels in 2002 to 2021 were a statistical tie, though still behind 1580 for the worst single year. Climate change from the burning of fossil fuels is bringing hotter temperatures and increasing evaporation in the air. So Williams used 29 models to create a hypothetical world with no human-caused warming, then compared it to what happened in actuality, which is a basically accepted way of doing such thing. So you can almost think of the hypothetical world where there's no human activity causing anything. You can think of that as like the control on the experiment, and then you run you tweak the parameters, and you see what the simulations reveal. That's kind of what he did. So he then compared what happened in real life when you look at if the extreme weather event is due to a climate change, and he found that 42% of the drought conditions are directly from human-caused warming. Without climate change, the mega drought would have ended early on, with 2005 and 2006 wet enough to break it. Without climate change, the mega drought would have ended early on, with 2005, 2006 wet enough to break it. The study is an important wake-up call, said Jonathan Overpeck, who's Dean of Environment at the University of Michigan, not part of the study. Climate change is literally baking the water supply in forests of the Southwest, and it could get a whole lot worse if we don't halt climate change soon. Well, with all the feedback loops kicked in, with the 240 zettajoules in the oceans waiting to diffuse back into the atmosphere, the warming trajectory is already locked in place. Whether we can end the drought, that remains to be seen. It's just hard to say. Williams said there is a direct link between drought and heat and the increased wildfires that have been devastating the West for years. Fires need dry fuel that drought and heat promote, because, as I discussed with you guys many times before, the warmer air can hold more moisture, and it does what? It sucks it out of the ground, drying out the ground. And Daniel Swain, a UCLA climate scientist who is not involved in the study, said climate change is likely to make mega drought a permanent feature of the climate of the Colorado River watershed during the 21st century. So, you've got, and I'm going to try to pull up the drought meter here, a drought monitor here. And here's the key here. So intensity impacts, white is none. And then you have different levels from 0 through 4. Gray is no area. So D4 is exceptional drought. D3 is extreme drought. D2 is severe. D1 is moderate. D0 is abnormally dry. So when you look at this here, you can see the red and the dark brown. This is where you have extreme, severe, what was the wording? Exceptional drought. So exceptional drought, extreme drought. But when you look at this, okay, even along the Mississippi, what is the Mississippi? Well, you got some of these, that's probably what, the Platte River? Missouri River, Platte River, I forget them offhand. But when you look at these major, even around the major river systems here, we see some drought areas. which is interesting because you would expect the riparian zone, not necessarily be in a state of dryness, but yet that is what we're seeing. We're seeing water levels drop. I mean, look at the western, basically half of the U.S. There, just about every place is in some condition of drought. Every place, whether it's abnormally dry or moderate or severe, extreme, exceptional, every place in the western half, maybe even 2/3 of the U.S. is experiencing drought. This is extremely concerning. Extremely concerning. As I have discussed with you folks many times before, as we continue to change the climate, as the feedback loops kick in, wet areas will get wetter. Dry areas will get drier. And granted, these are just two, you could call them anecdotal situations with the drought and the extreme precipitation event, but this is an indicator, perhaps a bellwether, that this sort of situation will become more widespread and more common, increasing in frequency. Because remember, warmer atmosphere can hold up to basically around 7% more moisture for every 1 degree C increase. That energy, that precipitation, has to go somewhere. So that's what we're seeing here. Wet areas getting wetter, dry areas getting drier as the planet warms. So, there you have it. Stay tuned. Well, continuing on here, richest nations won't escape impacts as global warming accelerates. And we see a city here, it looks like there's some flooding taking place. And judging by all the spots here on the lens, I would assume that a precipitation event is also occurring while this photograph was made showing the flooding. While the impacts of climate change fall first and worst on developing nations, the climate adaptation report released last week by the IPCC shows that the world's richest countries won't escape the unavoidable impacts of the emergency their greenhouse gas emissions have produced. Already, accelerating climate change hazards have adversely affected the well-being of North American populations and pose substantial risks to the natural, managed, and human systems on which they depend. And it's a report based on what's going on in Canada, the U.S., and Mexico, right? We've got the fires, we've got the heat domes, we've got the flooding, especially the West, droughts. The West Coast getting the shit kicked out of them. And then you go to the East Coast and there's constant, precipitation events dumping shitloads of rain, shitloads of snow, and it's just crazy. But it goes to what I have been saying for quite some years. Dry areas will get drier, wet areas will get wetter. We are seeing that. So even if global warming is limited to 1.5 C, human life safety and livelihoods across North America, especially in coastal areas, will be placed at risk from sea level rise. SLR, sea level rise. Well, it's not single lens reflex, huh? So sea level rise, of course, is posing a major concern. And along with, severe storms and hurricanes, because the oceans are warmer. They're going to suck up that energy off the ocean. The atmosphere is warmer, can hold more moisture. So it sucks up the energy, the moisture off the oceans. It can hold more of it and then proceeds to just piss it all over the land. In the UK and Europe, our current 1.1 degree warmer world is already affecting natural and human systems, with compound heat waves and droughts becoming more frequent. The analysis for Europe points to four key risks that get steadily worse as projected warming increases from 1.5 to 2 to 3. So, what are some of these risks here? Death from heat stress, increase in hot fire prone areas, reducing habitable space and biodiversity while threatening the continent's carbon storage capacity. Substantive agricultural production losses due to heat and drought, right? Basically, your crops fail. Water scarcity, right? Dry areas get drier. Boom, you suck the moisture out of the ground. We're seeing, what was it? Powell, some reservoir out, I think it's the Lake Powell reservoir, is dropping precipitously, like really, really low. And it's now an emergency situation. Flooding, sea level rise, with coastal flood damage set to increase tenfold by the end of the century at 3-degree average warming. Closing the adaptation gap requires moving beyond short-term planning and ensuring timely and adequate implementation. Well, short-term planning. When you have a system based on capitalism, that's all they do is plan for the next quarter. That's it. Anything that affects the bottom line, well, we can't have that. That's part of the problem, capitalism. So the Canadian press, reports that some of the impacts facing Canada, overall adaptation costs have risen from 400 Canadian dollars to 1.9 billion Canadian dollars per year over the last almost 40 years. Wildfire costs and the attendant human and community impact could hit a combined $459 billion by 2080. Holy crap. Above average sea level rise in Atlantic Canada. That's referring to the Atlantic provinces, New Brunswick, Nova Scotia, Newfoundland, PEI, Prince Edward Island. That's what they're referring to. With one Micmac community already looking into its options for relocation. If I recall correctly, I think Micmac is New Brunswick. Damage to fisheries, including squid, cod, halibut, kelp beds off the Nova Scotia coast. Water scarcity from Ontario through British Columbia and north to Yukon and the Northwest Territories that could offset the advantage of longer growing seasons and warmer temperatures by the 2050s. Longer growing season, yeah, but look at the soil. A lot of that land is permafrost with very acidic soil. Really not the proper soil type that's conducive to growing the crops that humans grow. So I don't know about that. Damage to northern transportation infrastructure due to permafrost thawing, not melting, beginning with the rail line to Churchill, Manitoba. Disruptions to international supply chain, markets, finance, and trade. We're already seeing that now, right? Across North America, the fact sheet says higher temperatures have already shifted wildlife habitats, particularly in the Arctic, with escalating climate impacts on land and the oceans and freshwater systems, compounding other threats to species and their habitats. Climate change has driven an increase in disease and death. And what diseases, what pathogens await us as the permafrost thaws? Ponder that for a moment. With the severity of impacts influenced by age, gender, location, socioeconomic conditions, those risks are on track to increase, that much more so with higher levels of warming. Water security issues are becoming more prominent, particularly in northern Mexico, western United States. Cities are seeing cascading effects of infrastructure damage, loss of services, economic activity, damage to heritage resources, safety concerns, and disrupted livelihoods. Impacts are particularly apparent for indigenous people for whom culture, identity, commerce, health, and well-being are closely connected to a resilient environment. For North America, a focus on indigenous rights and knowledge is critical to reducing climate change risks to achieve adaptation success. along with other equitable, inclusive, and participatory approaches to adaptation. European fact sheet calls for behavior change and building retrofits to combat heat stress, changes in farming practices to address crop loss, water efficiency measures, and land use changes to deal with drought, combination of early warning systems, adaptation options, managed retreat to reduce the impact of flooding. The issue of the crop is a critical one. As the temperatures increase, plants, like all organisms, have a preferred temperature range. They're not doing well. We're already seeing a decrease in crop yield as the temperature increases. This is being quantified. And in addition to that, the crops that are able to be harvested, the nutritional content is reduced. So you're getting less yield, but less nutritional quality for what is harvested. And when you get crop failures, it's going to lead to famine. Even if people are getting some food to eat, if they're not getting the caloric content, that's going to impact their physiology. So, I've been trying to cover the issues of crops with you, and as you can see, that's a major concern. Okay, so there you see it. No one can escape what's happening. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.